My name is Ayomide. I'm a full stack developer at Swift. Uh, I have about 5 to 6 years production experience as a software engineer.
Mm.
Uh, I started my career um, working for a startup building products using JS, fantasy sports systems. And before then, I freelanced briefly while I was in college. Then I worked for a software engineering consulting firm, which helped to build product lines. For example, we built a KYC product, and I also worked at Movinga, which is a logistics startup. We use it's basically the product is if you want to move. So, for example, you want to park from your apartment, from your office. Movinga facilitates you being able to move.
Mhm.
It facilitates the products being able to move end to end, if that makes sense. So, technology-wise, just like I briefly mentioned before, I've used Node.js extensively at all those roles, and
Mhm.
I see myself more as a product engineer, which means like I like having been involved in pretty much every aspect of the product, which is planning, execution, design, and even sometimes product changes and sales, being able to be involved in things like that. So yeah, that's just a rundown of myself.
Okay, cool. Cool. So which would you say you're stronger in? Have like a tendency towards respect to full stack? Are you more front end, back end?
Yeah, I would say I'm a full stack developer with a strong backend focus. So
Okay.
I work on the backend.
Right. Okay. So we'll be doing more like back end systems style interview.
Right.
Um, on your last job, what was your day to day like?
Okay, you can pin a. All right. I'm sorry for taking a detail. So at my last job, my day to day involves being involved in the planning of the part of the product you're working on. So at my immediate last role, I worked on the shift for business, so which was essentially a white label app for logistics companies to manage their logistics needs. So that involves being able to track the orders they have, being able to track the orders, being able to auto order, to uh, allow them not just track their orders, but basically everything that involves management, which is like being able to export all their orders, being able to assign drivers automatically and things like that. So my day-to-day activities involved being able to, having discussions around product improvements for this for my team, uh, working with the product owner, and sometimes also my day-to-day discussions involves collaborating between teams. So, for example, if the domain of what I'm working on also involves other teams, collaborating with other teams to get more context and resolve it and implement the change itself.
Right. Right. Okay. Did you ever have to coordinate other developers as well?
Yeah, I have a leadership role. I was in a leadership role for a brief moment. So I led a team of developers for a few months when I was at Enyata.
Uh, right. Okay. All right. So maybe let's jump right into it. So you have strong backend capabilities. So I'd present you with a theoretical situation.
Okay.
So we have um we have a floor plan of a company.
Mm-hmm.
We have essentially robots that
Right.
we can move like on that floor plan to maybe deliver packages from one end to another. It could be to, stack boxes. It
Right.
could be to basically do anything. But we basically have a floor plan and we have machines on that floor capable of moving between coordinates,
Right.
right? Um, so I mean, let's first start basic. How would you like in naive implementation? How would you stop them from colliding on the floor?
I would prevent them from colliding on the floor.
Yeah.
Uh, um,
Feel
speak.
free to ask questions. If you need to
Yeah,
ask.
yeah. It's to me, it's feels more like a theoretical, abstract question rather. But like,
Mm,
I know it's supposed to have like a physical implementation, but the idea. But what I really think is, speaking from the physical part first, the first thing you want to do is to make sure that they can detect each other, right?
mm,
So the first basic requirements, the first basic requirement would be that they are capable of understanding what is going on, at least to be able to recognize another robot, another agent. So that means, for example, being able to have a sensor, right? Being able
okay.
to gather data around. It could be an ultrasonic sensor, it could be a visual based sensor, right? So that would be the first thing. I mean, I would imagine that would be the first thing. Then it depends on the requirements of the floor. I mean, it's quite generic to say a floor with robots.
Mhm,
Well,
mhm,
let's say the use case is like, okay, you give a better streamlined example, a robot stacking boxes,
mhm,
you know, on the floor. So first thing I would do, apart from the fact that the robots themselves can detect each other and recognize another robot.
mhm.
First, the second thing I would do is to look at the parameters that's needed for the use case. So, which is, for example, how many boxes do we want to stack, things like that. Look at the constraints,
Okay.
right?
Okay.
Uh, how many boxes do you want to stack? What types of boxes are we stacking? What types of robots themselves, for example?
Right.
So some of these things, some of this decision informations inform the decision to actually do the planning itself and draw out the plan and everything. So overall overhead idea of how I would design it, at least to approach it. That's where I would start from.
Okay. Let's maybe walk down one of your ideas, right?
Right.
So with respect to the maybe like ultrasonic sensor. So
Yeah.
if it's the case where okay, fine, we do have let's assume these robots, these machines have like ultrasonic sensors, right? And I detect or I as a machine detect another machine in my path. Um, what exactly is the procedure that follows after that? Like what happens?
Okay. So I notice I know as a robot, as an agent, I see you and then I recognize you as an agent. The
Mhm,
the first thing would be to stop, right? I mean, the first thing would be to stop, the execution at that moment, and then make some decisions, which is since they are agents that are moving. So it's safe to say in this case, for example, to give an example,
mhm,
stop, then depending on the logic, right? You have an algorithm that tells each of the agents that, hey, you have more space for you to proceed with your operations. So in the case where they both see each other, they
mhm.
try to understand what is going on, then make way for the other one, basically. Uh,
So yeah, let's walk down that one.
mhm,
Let's walk down that path. So basically, like in this case, how would you then like let's try and maybe flesh it out a bit.
mhm,
How would you stop deadlock in that situation? Like if I and a machine and another machine like notice each other on like on a path to collision, right? Using the ultrasonic sensor. Maybe let's say it has some arbitrary range of, I don't know, you can only notice if it's like 5 millimeters away, right?
Okay.
Um, then what then follows? Walk me through your how do you break deadlock?
Speaking from the physical, it sounds more like a physical problem. I'm sorry, I'm just trying to walk through my train of thought at the moment.
Yeah, sure, sure.
So, to avoid deadlock in this case, so by deadlock you mean like the collision basically.
Yeah, like so no, not necessarily collision. So you mentioned that if they notice each other, like they stop, right? So at that point it's basically deadlock, right?
Right. Okay.
So what then happens?
Okay. So when you're in that situation, uh, for the logic, I would say number one, measure the distance between each of the agents, and each of the agents also measure the distance that's free around them, or if there are any other things around them. I don't know if that at least approaches what you're trying to.
So like in measuring measuring the distance, like what will we then achieve or
So,
like what?
so, so measure the distance. Then, depending on how free it is, like for example, you measure the distance for agent A to agent B. So, agent B is also free and like all around, like 5 meters around, 5 millimeters around, also to the left. But agent A is free 5 meters to the right, to the left and right, and can also move back a little bit.
We
Right.
basically dealing with the entire floor as like breaking deadlock. But let's assume um these are like fixed paths on the floor.
Mm-hmm.
So right, let's assume these are fixed paths. I don't want you to get out of it. Let's assume like these are like fixed paths on the floor, right?
Okay.
And so we are in a lane. We're locked in this lane. You
Mm-hmm.
can't move to the right. You can't move to the left. Then what happens? How do we break this?
I mean, your odds operation, I would imagine it's this. The question, I think it's feels similar to the salesman travel, at least, and the trolley problem rather. That's what I'm getting. The trolley problem of, hey, you have a train track with kids on it, then how do you stop this? What decision do you take? I think it's basically the same sentiment, right? That in that case, you're already on a fixed path. So not only is it quite deterministic to some extent, because, for
Mhm.
example, you could know at what point a robot is at that point, like at a specific point a robot is, because, for example, you know the specific path, you know how long the path is supposed to be, so you know what they're supposed to do, right? So you already know what's sometimes, like, it's already quite deterministic if it's already a straight line. So in that case, if there is something that happens in the deadlock, just like you said, I think the first step would be to halt operations, right? And then see if there's like a logical last reset, like the last working positions of the robot. For example, hey, everybody waits, then what was the last working operation that was safe without affecting your neighbor? For example, like if the conveyor belt, say the conveyor belt or the conveyor arm moved 10 meters previously before, then halt operation and probably go back to the 10 meters that the state of the operation was in, basically.
Mm.
I don't know if that answers your question.
Okay, so let's walk this down like the deterministic path, right?
Mhm,
Um, so if you say okay, it's all predetermined if there's paths,
mhm,
like it's all predetermined. So let's take that sentence and move with it. So if it's all predetermined, how can I maybe like beforehand prevent this kind of collision? So let's say you have your fleet of robots, right? Um,
mhm,
beforehand there's nothing on the floor, right? Nothing on the floor but predetermined paths,
mhm,
and there's each robot maybe already has like designated workloads to carry from point A to point B with respect to that robot,
mhm.
right? So then how beforehand can I allow these robots move on this floor without even running into the deadlock?
Mm, to be honest, nothing is really coming to mind specifically that could probably satisfy more. Like, I'm still trying to really understand what the specific example could be. So if you could just walk me through what you think or what you have in mind, then probably
Okay,
that.
let me flesh it out a bit. So let's reduce the scope, right, and say we have just three robots, right?
Mhm.
We have three robots. We have a floor plan, but on that floor plan, it's not necessarily like every space is accessible to you. Maybe there's predetermined parts on which these robots can move, right? They can move maybe in both directions. Like it really doesn't matter. You can move forward, you can move backward, but there's predetermined paths.
Okay,
For instance, you can't necessarily move out of those
just
paths.
like a track.
Yeah, like a track, pretty much. So how do I prevent these three robots? Like they already have maybe robot A says it wants to move from point A to point B. Robot B says B to C,
Mhm.
and robot D says, I don't know, maybe D to A, right? How
Okay.
how do I beforehand prevent robot 3 from crashing with robot 1, given that they are going to collide, given their origin and destination.
Give me a second. Let me think.
Or I hope it's clear enough, right?
Yeah, like it makes sense from the perspective of you have a track, then how do you make sure that while these robots are moving on these tracks, they don't collide, basically. I think that's like the
Mhm.
overall idea. So I mean it sounds more like having a central control of like logic that's of course, as you would expect, that tells the robots that takes information on where the robots are at the moment, right? So, for example, robot A is on the specific part of the track.
Mhm.
Uh, Even before they collide, they should also be able to communicate between each other, for example. So then the robots are communicating that, hey, even though I'm at this position, see it as more like a GPS, a GPS system or a GPS broadcast, right? So I'm at this position, then you can find me here. Then others can use the same information. So, for example, get the distance and be able to stay off, and So I would imagine, or I would take chance, or I would take opportunity of something like this, right?
Mhm.
Actually have the robots being able to communicate with each other at least, and then the logic that specifies that, hey, if the distance, for example, between the robots are reached, I think sarcastic is saying something. If the robots are, if the distance between the robots have reached a particular distance, for example, then you want to make way for another one, or you want to slow down or speed it up, or you want to halt operation for that specific robot.
Okay, so
Operation.
you mentioned basically it's sort of like broadcast, so broadcasting your position
Mhm.
to other robots, so they can basically know where you are without running into you, right? So maybe let's walk down that one.
Okay.
um so I can broadcast my position to every other robot, and every other robot broadcasts their position to me,
Mhm.
right? So how do I handle the case where um I've scaled this up from 3 to maybe 1,000,
Okay.
right? So there's every given second 1,000 uh positions, or
Okay.
999 positions coming from the other robots to myself.
Okay.
How can I optimally maybe compute if I'm in anyone's way, or how can I stay out of everybody's way, or do I just get frozen in time? Like what happens?
Yeah. I'm not really sure what you mean. If
So okay, so we have, so now we've gone from 3 to 1,000.
Okay. So more like having this thing like the train tracks that we're watching for the collision and things. So having multiple of them at scale, like having a lot of this factory floors, for example.
Yeah.
Okay.
No, like not the factory floors, the machines themselves. Like the factory
Sorry,
floor
machines.
just yeah, it's still just one factory floor, right?
Okay.
For now, we have 1,000 machines, but
Mm-hmm.
everybody has to broadcast to everybody else, right? How
Mm-hmm.
do you basically handle that? That sort of sounds like a mesh network of sorts, right?
Mm-hmm.
How do you basically handle like that communication, and how do you say, okay, like what's your algorithm basically? Like how would you make it that I as a robot can compute my distance to everybody else and then plot my next move? Like what are like the series of steps you do for that? And this is in respect to what you said, right, about me telling every other robot about like where I am currently. So
Mm-hmm.
what would I do with that info if I am one out of the 1,000 and I've received maybe 999 positions, right? How do I go about that next?
Yeah, so you scale this up and then you get a lot of information that you're receiving.
Hmm.
And, of course, I think you would need to understand the data that you are receiving in the first place. So let's say you already get a lot of this data, and you already got for a lot of robots. First step, you want to check if the robots around you, um, the data you have on those robots around you. I mean, the whole idea we are trying to do is to avoid collision, right? So to be able to act on your own without harming others. So I would imagine the first solution will be able to check for like ranking this location broadcasts, like knowing each person that sent you this information, and checking if they are close to you, for example. Um,
How would I check if they're close to me, right? Like giving their location data.
yeah, you could use various ranking logic. So for example, you could say you're ranking based on your location at that moment. I mean, it's a quite direct mathematical problem in that case. For example, how far away is the closest other agent at the moment, that type of thing. And hey, I'm at position X, Y, and Z at this time. So who is the nearest person to me, regardless of who it is, because I get a lot of information. So number one, I already rank it based on my distance, for example. And
So what would optimally compute this? Would this be like the central control, or every robot does this for themselves?
I think to some extent, every robot should at least be able to find the distance, like to be able to understand the distance to the distance they are to the closest other robot. If that
Okay.
makes sense. So, for example, they should be able to detect, hey, at least another robot is close enough, but a central processing system could be responsible for more complex logic. For example, collating all this data, and then depending on analyzing all this data, and then being able to watch out for example, the probability of a part of the system actually having this deadlock. For example, if some of the data, some part of the in some of the data in the system that we're getting is that at a particular region, you tend to get a lot of activities, right? So you probably want to watch out for that, right? For example, then you analyze all this data in the system as a whole to be able to probably look out for what's part of the systems, which robots might be affected by deadlocks soon. But individually, at least the robots themselves should be able to, for example, be capable of some things on themselves, like operations on themselves, being able to detect how far away another robot is, and broadcasting where they are at the moment.
Okay. Um, so what would be the downside of maybe let's say every robot doing this for themselves versus
Mm-hmm.
central? Like what would you give me? Like if I asked you to maybe state the advantages why you would go over like a central system
Yeah.
versus every robot trying to compute it for themselves, what would you give me as the argument for either?
Yeah, I think number one, it has to do with costs, right? So let's say the robots are already expensive enough. You would need way more computing power um, if you have like you spend more on computing power, like a centralized computing power, if you use like a centralized system, because then that means everything is running on that hardware alone, right?
Mhm.
So number one, you need it's more expensive in that regards. Then on the other hand, if you have like some of these things running independently on the robots, like it might be easier. Like it might be easier, for example, the robots, the computing power is enough for them to be able to do what they want to do, right? So in that case, uh, excuse me, I'm trying to get on my thoughts.
Yeah, yeah, sure.
So in that case, it's easier, I would say. In that case, for example, if you're trying to just allow them be able to offload the some of the work to be done from a specific system. So, for example, if the main system goes down, like it might affect all the robots, for example. That's another thing to watch out for. So
Mhm.
it depends on if you are going for the reliance, the reliability, or you are going for the consistency, and the caps here, and basically that, hey, I want to make sure that every time my robots can broadcast information about where they are, right? And be able to read information about those closest to them. But that should be it. Or should it be that my robot should be able to not necessarily do this, but they can have a faster reaction time. For example, a lot of the computing power is spent on faster reaction time that the robots are able to halt immediately or quite faster, for example, in case they are going into um, a deadlock or a collision. So another thing I can think of, the difference between them, the advantage or disadvantage, depending how you see it, could be that when you have a centralized system, it's hard to actually when you have a decentralized system, it's harder for you to issue instructions like to these robots. I can imagine it's a step harder, right? For example, because they can perform some actions on their own, so I guess it's a step harder to issue command to those robots. I would imagine, yeah.
Okay. So you mentioned cap. Would get back to that. But okay, let's still walk down this thing a bit, right?
Mhm,
So okay, we we say we have this functioning system, right? We have
mhm.
this functioning system, but we already have predefined tracks and everything. Um, so now we want to take out those predefined tracks, right? This floor is open to anyone.
Okay.
You can move anywhere you want to move,
Mhm.
but I'm taking away your ultrasonic sensor.
Okay.
So you don't have your ultrasonic sensor. I'm taking it away, but the floor is now open, right? So basically you can configure them to move anyhow you want. How are you still going to avoid this problem? Like
Um.
that's basically like deadlock. Like how would you avoid how would you avoid deadlock or collision? Like how you stop them from crashing to each other? There's no ultrasonic sensor,
hmm.
but the floor plan is open. You can move anywhere you want.
That sounds like chaos to me. But to be honest, I'm not really sure in that case. I
Yeah,
mean,
but let's let's try and figure something out, right?
yeah, yeah, okay,
And
it
the
makes
plan
it
plan's open.
complicated, but I would imagine number one, you're trying to speed limits. I would imagine. So, for example, you you try to move way you try to move slower. Yeah, that's the word.
Yeah, but we move slower, we still crash. We just crash slower.
Yeah, yeah, you still crash. So, I would imagine like having, for example, it comes back to say, uh, mm, give me a second, give me a second.
Mm.
Um, could you like give me like
The scenario, right?
a scenario like
Okay. So we have the system, right? But we have 1,000 robots as usual. There's no tracks, right? But everybody each has packages to deliver from one point to another. So what you have access to now, you probably, let's say, maybe have access to, every robot knows their origin, they know their destination,
uh-huh,
right? Um, and you can move basically anywhere on the floor,
uh-huh,
but you don't have like an ultrasonic sensor to sense in front of you that, oh,
hmm,
there's robots B in front of me,
right?
right? So even if we do limit your speed to a certain cap, like you would still run into robots, but just slower. So
Yeah.
how can we, like, even before they start moving, like let's try and maybe come up with something that can potentially stop them from running into each other.
Okay. Let me think. Mm, mm, mm. Nothing is really coming to mind. Sorry, because I really can't imagine how you would, at least without some basic information about avoiding others and telling others where you
Yeah,
are.
no, like there's still, so you okay, so let's assume there's a central system that everyone can communicate with, right? Everyone can communicate with, and maybe let's throw in a bit more there. Like everybody reports their current location, and they can potentially report other things
Uh-huh.
to this central system.
Okay. Yeah.
Yeah.
Okay. That makes it a little more different then.
Hmm.
Yeah. Since we have a central system, the central system will be responsible for coordinating things in that case.
Okay. How?
Yeah, the central system will have um, an algorithm that's number one, uh, uh, ranks like it looks at the position for it does essentially what each of the agents should have done. It takes a look at the proximity of each of the robots to each other to detect if they are on a path of collision, for example. So it's responsible for gathering information from like the central system is responsible for actually doing the logic that separates them and keeps track of each of the robots and then um, does the job of computing the coordinating the distance, detecting the distance, and saying robot A is far away from this. To be honest, a specific algorithm is not coming to mind, but I imagine like
There's no specific algorithm per se.
yeah, but I imagine like you would have like a some sort of algorithm that ranks the distance for each of the agents to know which one is closest. I feel like that is one basic thing, at least one minimal thing that
I mean, okay.
uh,
So what do you mean rank in what sense? So would that
so,
be
so
because
like yeah.
it can be close, right? But we're not necessarily on a path to collision.
Yeah, it's true, exactly. So it's
So how would the algorithm work?
yeah, in
What
that
would it
case,
take into account in that
yeah,
case?
in that case, the algorithm will just take into account that even though they are not on the path of collision, they probably interacted. This was the part that they interacted together with. This was how close they were. So I mean, it doesn't necessarily have to be until you're on a path of collision for you to actually get this kind of information, if that makes sense. So it's just to know what is what at that moment around you. It is not every agent that's around you that's probably going on a path of collision with you.
Hmm.
Exactly. So
Okay, so let me throw one more thing in there,
okay,
right? Um, so let's then assume so let's make this more practical, or at least with respect to processes,
okay,
right?
okay,
So these robots are full processes in,
okay.
in a system.
Mm-hmm.
Um, how would they typically So we're accessing a shared um data structure.
Okay. Okay.
So how would we prevent ourselves from colliding? Pretty much.
So you could have a global store, right? That
Hmm.
has you have a global store with
Hmm.
all the robots. So in the central system, for example, it has a global store which all the robots puts their information in, right?
Hmm.
So how you would prevent a deadlock would be like to use a mutex, for example, to use a lock. So each process that's trying to read at that moment is the one that's can get access to it at that
Hmm.
point.
Yeah.
So it locks it to that specific process, and the specific process is, hey, okay, this is what I have, take this.
Okay.
Then it gets back and then unlocks to allow for others to be able
Yeah.
to. Okay.
Let's exactly. Let's walk it down with that. With respect to that. So now you mentioned mutexes, which is what I was like trying to push it to a bit, right?
Yeah.
So, now how would you like walk me through like maybe A to Z of how will I then use mutexes to make like these processes not like collide into each other on the floor? What's the first thing I'll do? Like there's free reign. We can go anywhere we want, right? We can't see each other, but we are all reporting to the central
Yeah.
system.
So
How
I
does
would
the system stop them from colliding?
Yeah, so I would imagine the central system, we have some sort of mutex lock and unlock in place.
On like what does a mutex lock on?
So on the floor, for example,
Okay.
everybody is sending information, right? We can't see each other, but we are sending information to a place, right? So that time that I'm trying to send the information there, I'm trying to say, hey, this is my position, right? I will send my information to a central place in the central processing center. Let's just say that. So I send it to the central processing center. This information or this ability is shared by any of us, right? So it could
Mhm.
be from any robot. But at the moment, I'm trying to talk to the central to the center, what ensures that no other robots will be able to also put their own information at that moment while I'm trying to do my what prevents other robots from being able to do that is the mutex lock. So
So
it's
what information am I putting on there exactly?
yeah, good question. So for example, in this case, that would be the broadcast of your location, for example, where you are at the moment, and
Okay.
at the minimum, at least, then the central system can deduce a lot of other informations from there. For example, if I broadcast at the moment where I am, and another process or another robot broadcast where it is at at that point, the central system can still calculate, for example, how far we are in between each other. But at the moment, oh, sorry, at the minimum, as robots ourselves, the information I will put globally that will say, hey, this is what describe what I'm doing at the moment is at least it contains the position, like the position on the floor, where the robot is at the moment.
So I'll along the line of um so with respect to that mutex, right? I'd say so we could one thing we could do, right? And we could work this the way you said,
Right?
right? So you send uh each robot before it communicates with the server,
Mm-hmm.
sends or when they want to communicate with the server, send try and acquire the lock,
Mm-hmm.
and place their info. But so if I place my info as like my position right now on the system, the server then calculates my position against everyone else's position and tells me um if I'm on a collision path. Is
Okay.
that
Yeah. The it's Yeah, it could. It could involve detecting if you're on a collision path. I mean, that is the whole idea at the end of the day. That's what you're trying to avoid. The main
so
responsibility.
if I am on a collision path, then what does the main server then respond to me?
Yeah. If you're on a collision course in this case, I'm not sure how that ties into the. I'm trying to tie it into the idea of processes, just like we did in this case. So that means we are having if it happens that at that moment I'm trying to push something and another person is trying to do the same thing, that means we are going for a collision, right? Let's just say that is what collision is at this moment. So let's define collision as, hey, this is my robot, and based on the information, my robot is trying to put the information in the global store and say, at this point, this is where I am, right? So that means so far it successfully puts the information there, right? That means it has not collided. So
Yeah,
collision,
but even if two of us put our positions there, that's not necessarily a collision, right?
yeah, it's not necessarily a collision. I'm just trying to like ascertain what collision is in regards to.
So collision means like
So yeah.
yeah, in this sense, right? Collision in physical sense of these robots means we are going to collide if we continue on this trajectory. Trajectory being the keyword, right?
Yeah.
Um, and yeah, collision in the process sense means we deadlock on some, you know,
Yeah.
on some object, right?
Okay. Well, so I guess going for the physical collision, that's a question, right? Like,
Yeah, yeah. Like how does the central system then like say like how does it come? Like I'm interested in like maybe a bit of like step by step. You don't even have to like it's not there's no math algorithm that you have to like specifically hash out, but
yeah.
like just walk me through the steps of how we would like
Mm,
the central system would stop them from hitting one another, given that it has this info, right?
mm, yeah. Give me a second. Give me a second. So, mm, you know how far it is from each other.
Hmm.
You can find the distance. So like you can find the location of already at the moment. And well, I would say the central server would just number one have like a ranking logic uh, that
Okay, so ranking.
is, yeah, a ranking logic that specifies that um the minimum distance, if if two agents are at this threshold, for example, of
Hmm.
distance between them, um, then you could probably you could probably treat them as probably going to be on a collision. So you could have a logic that, depending on how far away the robots are, to detect the chances of collision. So it's not necessarily about okay. So if you want to have a step by step, um,
So maybe let's track Spark, right? So let me do it like this. So let's assume on that floor, right? We split that floor into multiple grids,
mm-hmm,
right? So we can take each of these grids as a possible position that any robot can be in, right? Like we split this floor into let's say the boxes that we
mm-hmm,
split them into, right, can at any point accommodate a robot and its load,
okay,
correct?
yes,
Yeah, so they can accommodate a robot and its load. And then how do we then like given this split now, like how can we like use mutexes is basically what I'm trying to get you to do. Like we've split it up now into grids. We have a central system.
mm-hmm.
How do we get them to move without hitting each other?
I'm trying to think about how it ties in with mutex. For example, like how it ties in with mutex in this case. I'm sorry, nothing is really coming to mind in that regard. So if
Yeah.
just tell me what you think.
So if we've split it into grids, right?
Mhm.
You can take the grids as basically critical sections of a code, right? Anytime you don't want someone to be in a critical section besides you, you basically want to lock it in some way,
Mhm.
aka in this case mutex, right? But you could look for something more optimal.
Mhm.
So before robots A moves from point A to point B, it tries to maybe take a lock across its entire path. It can either take the lock maybe grid by grid as it moves on, right? or it can say, okay, before the end of time or until the end of my path, I want to lock all those paths. I want to lock all those blocks, right?
Yes.
So then when I pass by a block, I basically release it, right? So anyone else can then lock that. If I pass, some other block, I release it. Do you get? So that way, even if you were going to collide with me and I booked those blocks ahead of time,
Oh,
you'll be able
okay.
to get to that position because I would be holding the lock.
Yeah, I think I better visualize the overall problem when you.
Yeah, yeah, I'd be holding the lock, right? So another way we could do is was what you were trying to like with the whole geometric thing. So we could geometrically say, rather than picturing it as like a 2D plane, right? We can view it like a polygon intersection problem, right? So as you are moving as a robot, you basically have this polygon of sorts around you,
Right.
right? And you can then send your details to the central server. The central server has everybody's polygon at that point in time, right? You can basically expand this polygon to give, I don't know, room for when you guys are like some intersection threshold, right? It doesn't have to be the perfect size of your robots,
Mm-hmm.
right? And then like when these polygons intersect, you can basically, stop it and have some arbitrary logic to, I don't know, go around or try some other routes or whatever. But basically, the more, I guess, more prevalent, I'd say, I'd lean towards, or less complicated, with respect to like the math, is just taking simple locks.
Yeah. Okay. Yeah, that makes sense. It sounds easier actually, and
Yeah,
I
taking
better
simple.
visualize the problem now. Thank you for that.
Yeah, it just takes it. So maybe let's step into something else outside locking, right?
Mm-hmm.
Um, so what's your like experience with databases? Like in general, what are you worked with in databases?
Yeah. So I've worked with SQL and NoSQL databases.
Mhm.
So I've worked with when it comes to NoSQL, MongoDB, which is a NoSQL database. Sorry, a NoSQL documents oriented database. And then I've worked extensively with PostgreSQL when it comes to SQL. So yeah, those are the two major databases, and I don't know if you would consider it a database, but I do use Redis for caching too.
Perfect.
Yeah.
I also like Redis a lot.
Mm.
I also like Redis a lot. So let me maybe ask you some DB type questions, right?
Right.
With respect to Postgres now, when, or I guess any DB actually, when would index, right? Like when would you use an index? Like what would push you to use an index? What's an index? How does it help?
Yeah, to make retrieving or searching for something faster, basically. So, for example, an index would be something that I have 1,000 records, so an index will make it faster to be able to get my results from that 1,000 records.
How does it do that? Right.
So it does that by it depends on the type of index it is.
Mhm.
I'm a little bit rusty to be honest, but
No, no, you don't have to give me specifics. Like, yeah,
so
generally, how does it just do that?
yeah,
Right.
so it could create like a table, for example, uh,
Okay.
that contains the sorted this it contains this sorted results.
Thought is the keyword I'm looking for.
It contains this key, and then it has a pointer to it in the main database itself,
Yeah. I
right?
guess sorting is in this case is the word I'm looking for. If
Okay.
at least with respect to, yeah, some
So
of the types of indexes. Yeah.
yeah, exactly. So it gets from this sorted list, like it has all the sorted lists from the table, for example. Then let's say it uses the key. Sorry, it has all the sorted lists in a table, in a separate table, and then you have a pointer from there to the real data on
Right.
the
Right.
main column itself, on the main table, sorry, themselves.
Okay. Okay. That's That's fine. Okay, maybe we'll step out of indexing a bit.
Right.
And um, okay, so you're familiar with like the term like like interprocess communication, right?
Yes.
Okay, so
Mm, actually,
yeah, generally, how would you maybe, or let's not call it like interprocess communication, right? Like, how would you basically get maybe two of your services to communicate, right?
yeah.
Like, what are some of the ways you would get two of yourself? Like you're working with um I don't know, maybe you're working with Zoom, right? How
Right.
would you have two completely different processes or services running? How would you get them to communicate? How would you synchronize this communication? Like, could you give me some of the ways you could get them to like generally communicate?
Yeah, sure. So if you mean by communication, for example, you have two services, how do you communicate between them? There are
Mm,
various ways you could do that. You could go with HTTP. You could let them communicate over HTTP REST. There isn't something that's stopping you from doing that.
mm-hmm.
Then you could have IPC or RPC, just like you said. So which is essentially describing the execution that you want to run on the other computer. Right. So you're just telling the server that, hey, these are the parameters I have or that I take. This is the method. Then run this logic basically on the other end, like from 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 my
I think both of these are like based on like sockets, right?
sorry.
I think both of these are based on socket, like HTTP sockets, RPC, I think is still sockets.
Yeah, you could. Yeah, like if I remember correctly, for example, I had a I think I forayed into some blockchain products at the point. So to communicate, you would have an RPC communication over WebSockets. So I think you could use communication over WebSockets like your
Yeah,
RPC,
yeah, but
but
I'm saying all
it's
of them
less
are still based
similar.
on
So yeah.
so like maybe is there any other, I guess, like non-socket example? Like these are all, if I call via HTTP or I call via WebSocket or I call via RPC, it's still
Mhm.
socket based. All right. How would I, is there anything that isn't socket based?
Mm,
Communicate.
I'm not sure what you mean by socket based. Like,
Like these are all socket, these are all built
are you
on
saying HTTP itself is socket based, or because if you are communicating over HTTP REST, for example, you're not necessarily making a socket connection. So unless you're saying communicating between two clients has to involve sockets one way or the other. So
so
if you just
socket, a socket file is opened anytime you are doing anything TCP, right?
oh right, that's
Yeah.
true.
So that's what I meant by socket based. So all
Okay.
these protocols are, I guess, socket based.
Okay. Give me,
Is there any other thing you like we typically do? Maybe that like we don't explicitly maybe use sockets.
I'm not sure. Nothing is coming to mind.
Like message queues. You could use your message queues, right? I don't know.
Yeah,
That
but I imagined in this case, I message queues didn't come to mind because I typically would imagine. I believe message queues are for like to perform an action which you can then later come back to check.
yeah, but like I mean, communication doesn't necessarily mean instant communication, right? Like
Mm-hmm.
communication is still communication, regardless of when maybe you respond to me or act on that. I've still
Actually, yeah, you have a point because if you have like a pops up, for example, you're still communicating one way or the other,
yeah, pretty
right?
much.
So it's you publish one, then the other ones will take over. Okay.
I mean, it's another simple one that we I guess briefly touched on before was like shared memory, right? Where we spoke about lock. So if there's like we can just be sharing the same memory. Like if I keep uh info in Redis,
Mm-hmm.
and service A accesses that info later, we still communicated, right?
Mm-hmm.
Somewhat. Yeah. So I mean that's fine. So maybe like moving on final, um I guess like you said you're familiar with Rust.
Yeah, I am.
Yeah. Okay, so I mean this one is a cinch. Like how do we like garbage collect in Rust? Like how do we do that?
Rust doesn't have garbage collection. What it ensures that it does, it has a specific set of rules that make sure that your memory is freed at the end of the day manually, without you necessarily manually directly unallocating memory. So it's just a set of rules that make sure that when your memory is no longer needed, it's actually freed so that the computer can do whatever it is with it. So it doesn't have a garbage collector as this.
Mm,
Um, and this set of rules is they are typically built on lifetime ownership. So lifetime is how long a piece of data, let's just say that lives, for example.
mm-hmm.
So you call a function inside another function. One function lives longer than the other, right?
Yeah.
So the lifetime of whatever is inside the inner function is definitely different from the outer function, because the inner function could finish running and you could have a rest of the body for the outer function. After the inner functions keep running, other things could still be run in the main function. So it could have a different lifetime. For example, it could live longer, or it could, So then that's lifetime in a nutshell. Ownership is basically I possess this data at the moment, so it is only me that can actually do something to this data. So for example, I have a variable because I don't know what might happen to this variable at the end of the day because there's no garbage collector. So I can't just be careless with it. So Rust will be by default, Rust is immutable, right? So if you want to mutate it and you say, hey, for this variable, okay, mutate it, but I still own it, but another person can borrow it.
Right.
Right? So,
Okay,
so,
that's fine.
so just to run like to finalize that train of thought. So it's more like it uses this paradigm to make sure that your data is dropped at the right time. So because, for example, Rust has these traits. So it has these traits that automatically, when that part of the code has finished running or executing, it automatically drops. So it automatically implements drops that actually clean this up and then free it from memory.
All right. And that's fine. That's all for me. I think we've basically exhausted our from when you came in.
Yeah.
So yeah, I mean it was a relatively good session.
Thank you for this. I've not really had a preparation of this kind in a really long time, actually. And I hope I was able to, follow along with some of the questions. They felt a lot not so visual to me, to be honest.
Yeah,
Like you have a robot, and I was just trying to tie it to processes and things like that. So
yeah,
thank you for that question. That was really helpful.
yeah, it's fine.
All right. Yes,
Yeah.
sir.
All right. So I wanted Diretnan to maybe you can go over some things you think may have been improved upon in the whole um, chatting process, in the interview process.
Oh, okay, okay. I'd say yeah, you actually have like a strong knowledge base already, and you have like experience, right? I'd say maybe with respect to like abstract concepts, abstract backend concepts, anyways, or systems concepts. When you need to build systems, right? Like these are not like maybe explicitly DSA things that you would do, but like if you work with backend on a day to day, like you would run into indexes which you answered well, but you know you'd also have to run into things like locking, deadlock. You'd have to run into things like, okay, how do we communicate the different ways we can interprocess communications, like without necessarily being told like the name, right? So I mean, you have a very strong knowledge base. So I feel like these are all niggly things that you could just work on, right? Like it's not, these
Yeah.
are not like maybe huge deal breakers,
Thank you
right?
so much. Thank you.
Yeah, I think that's all right.
All right.
Okay.
Yeah. All right. So thank you very much. Let me point
Yeah, I
out a
think
few
I have a
things.
question. Black, yeah.
Yes. All right. Chinese, please go ahead.
Yeah, sorry guys. Good evening. I've learned a lot, honestly. So I just have a general question, might not be related to interviews as well, specifically, but I'd say my question is pretty much, how do you feel like, or what is your suggestion or recommendation for someone who feels like maybe they are like stuck at like maybe like mid level and really wants to like push like upwards? Do you recommend like becoming better at maybe systems architecture, or is there a specific thing like as a backend developer?
Yeah. Okay. If I can answer that, the question is for me. Yeah. So, if I if I can answer that, so I would say just like it's everything in pretty much everything in software engineering, it's practice and building and doing. So, for example, to step up, at least somebody that is mid level already have an idea of what they're doing. So to step up is just a matter of looking for the opportunity. I would say it's also depends on where your career is at the moment, right? So being able to actually see a career opportunity that actually enables you to do this. For example, it's a startup or company that works on interesting things, and then you get to expand on your knowledge. Um, I would say number one, that's it. Practicing and building. Personally, for me, that is how I step up on the concept. So, for example, indexes, just like Diretnan mentioned when we are talking, indexes. Even if, let's say, I've never used indexes before, and I was curious about how indexes work. So on the API I have on Zoom, I use indexes to make things faster to be searched for example. Is it user profile? Then I was able to actually get into the details and say, okay, this is the advantage of indexes, for example, to make this faster. I have a sign up endpoint and I want to check if this email already exists. It could be any email. I could have a billion records, how to make it as fast as possible. So I think it all stems from actually doing and getting hands-on with it, and then having like in your career getting lucky or working towards it and working in a place that actually enables you to do this. Because at the end of the day, you're an engineer, and even if you learn on your own, you build on your own, you practice, that's what makes it a career for you. You still need to have a way to like impact this in a real life scenario, so to speak. So which is why having a good career opportunity too is is actually big on how you step up. I know it might sound like, but you need the experience to be able to get a good career opportunity. But it is what it is.
And one thing I'd add to that, like in general, is so yeah, like you said, just build stuff. If you are mid level, right, it means you know the basics. You know the basics, and you've used them well. You use them over time. So what's the next thing you do? Just look under the hood of some of these things, right? So when you are building, no longer build like someone who is building the basics, where you just, okay, I'm fine with just calling an index or just saying, okay, index me this column, right? For instance, right? And then you figure out, okay, it's not actually faster. Why is it not faster? Why queries are not faster? In fact, your queries could be slower if you're indexing and maybe indexing the wrong thing or not using indexes, right? So peering under the hood helps, right? Peering under the hood, sometimes even building some of the stuff you see under the hood, right, also helps get like a general image of how these things work. So I'd say just build a lot of stuff. Ultimately, you might not use it at your job, you might use it at your job, but it generally makes you a better engineer, because if you can learn how some of these stuff work, like these are like time proven, comp sci like algorithms or concepts, right? So if you can learn them at some other point that might not even be related to databases, right? You might have like an outlet to use them, and you have the know-how now. You're like, oh yeah, this sounds like a problem that we can index against, or this sounds like a problem we can use mutexes. You get? So yeah, just try and look under the hood a lot of these times, because yeah, these people that wrote these libraries are not like aliens. They also use these things as well. So yeah.
Thanks a lot.
All right. All right. Thank you very much for the question, Chedo, and for the answers, Diretnan and Ayomide. So I'm just going to just list a few things, um, more for the purpose of others who are here. Some things I noticed during the question and answer process. So personally, I took it more like I mean, it's a mock interview. I took it more like an actual interview, and I think just to point out a few things. First of all, I think the questions were really, really good. Um, they really contain lots of concepts. I mean, it's 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 easy to think that it's just an abstract question and there's nothing really to learn about that. But when you go really deep, you begin to see lots of in-depth concepts. I never knew that you talk about mutexes and things like this. I mean, even I immediately was surprised. Yeah. So just a few things. First of all, I think that introductions should contain more flair. So um, yeah, I think self-explanatory. Introduction should contain more flair. It's easier to make a really, really good impression at that first point in time. So things don't take a, should I say, a low tempo at the start. Then you can then control tempo as time goes on. Secondly, I think we can ask more questions to understand what's going on. Um, to really get context or to even pin down the questions. Sometimes, when we started the question about, okay, you have robots and you have several floors, and these robots are stacking boxes. How do you just make the whole process smoother? I think several questions can be asked to ensure that you can pin down what questions are being asked, and then you can provide the right answer, such as, okay, can payloads be different? Do we have categories of payloads? Do we have ranking to the payloads? Do we have any sort of priorities? What guarantees do we want to provide in this whole system? With that, it's easy. Yeah, it's easy to be able to come up with an answer easier that way. I think something like that. And yeah, basically, the last thing to say is just, it's better to ask more questions and to ask for tips than to assume that the question has no known answer. Um, because we may not have thought of solutions to these answers. Whoever is asking the question probably has thought of an answer, and they have a keyword or something they're expecting you to say. So I think it's better to flesh things out, play around with the ideas, and that way you can easily get yourself in the direction of what the interviewer is asking. So that's all I would say. To
I
be
think
honest,
that's the key part of it. Like your introduction, I really like you've done a lot of things, so you can be more confident in your introduction rather than like low tone. So like yeah, sell yourself. You've done a lot, so sell yourself with like confidence.
Thank you. Thank you for that. I'm going to improve on that.
All right then.
yeah,
I think that's all for today, right? So
Yeah, and
yes, sir.
just putting it out there, I wouldn't mind having another session. Not necessarily me being on the hot seat, but just like a general
right.
session.
Do you have any review for me as an interviewer? Because I think
Yes.
I've only, I've only interviewed
Yeah.
Yes,
Yeah.
sir.
yeah, I've only interviewed one person. So I
All
don't
right,
have interview experience as well at this time.
all right.
Yeah.
So okay, maybe you go ahead first, then I'll go
Yeah,
next.
so I think you did really well. The question was really nice. Like the more you think about it, the more you realize that it's actually way more complex than it looks like. You know, so you might think it's an abstract question, but it's actually a real stuff that will lead to discussion. So, but an area of improvement could be it could be helpful to at least help set some parameters. I mean, I could have asked the question to lead towards some aspect of that, just like sarcastic said that to get to pin down the question. But at the same time, it could be helpful to be able to detect quickly if to detect between a candidate that's actually totally failing or just trying to narrow it down to a concept. So once detecting that earlier and actually being able to provide like a little guideway without still giving it out, if it makes sense. So it's just being sensitive to, is this person getting it, and should I quickly just chip in a little bit to establish my context. So other than that, I think that was just pretty much it. But it was really nice and really good question. I think I need to. I don't know how you came up with that, but that's a good one.
It's something I'd actually just been speaking with one of my guys recently, right? And it was just like this whole talk about like there's a lot of like distributed systems problem that we've been doing at work, at least I personally. So we just try to like narrow this down to some sort of like simple example or like how you would use maybe distributed systems ideas like blocking, mutexes, and things like that.
Uh, okay,
Yep.
thank
All
you.
right. All right. So let me. I just have two things to say.
Okay.
First of all, I should commend you for how dynamic your questions were. So, based on the answers, I think Destiny just talked about on the group chat. Based on the answers that Ayomide would give, you'd have several questions to ask. I think it shows your depth of knowledge and how well you've explored the question. I think it's a very important thing when interviewing. You should know, you should have explored the question to several depths. Um, person you're interviewing may have explored to several depths you did not think of. So it's good to have that grasp so you yourself don't get stuck. So that's one. The second thing I'd like to say is that you should flesh out the answers to the question. So I think it's usually helpful moving on to the next questions. I did jot down if not all the questions. I wrote everything down. So it's very good to have to flesh out answers to a category of questions. For example, when we talk about the idea of scaling, robots are no longer what's an argument for and against central control compared to robots handling computation and application. I mean, for three robots, you can go for the central control thing. That's no problem. When we now get to the point of scaling, you get, and we talk about scaling, we handle scaling at length. I think it's good to um, to kind of wrap up the discussion around that part. Just give you a few tips. Okay, so we can do this way. This answer you gave is good. We can do this way. We can do this way. It helps the person being interviewed to be able to bring up more thoughts because sometimes when you ask these questions, I think that to an extent, I don't really know. To an extent, while Ayomide would have had better answers, maybe if he was in a much more should I say, maybe a relaxed, very relaxed environment. It is difficult to come up with these answers when you've been
Yeah.
bombarded with several complex questions and you don't really have a kind of brain release in terms of answers to this question. Okay, I mean, when you mentioned, okay, when you introduce grades and you can lock a path in front of you, that's where mutex is being introduced. He grasped it immediately and
Yeah.
we're able to move further on the idea of mutexes in general. I think that's one thing that should be done. And lastly, I think the question should explore several areas and not just the idea of. Um, I think it's really good, really balanced on the idea of backend. We did not spend so much time on databases. I think there are several people who may have strength in a particular area based on companies they've worked at and they don't have strength in a particular area. So you can have skilled results if the questions are based on a particular thing. Some are really good at databases. Like everything you need to know about databases, they are your go-to guy to get. So it's easy to have a well-rounded view when we go through several questions and different areas. So that's all I have to say.
All right. Thanks a lot. These are really, really helpful feedback. I will take them into consideration. I appreciate it. Yeah. Okay, this
Yes. All right. Yeah. So before we go, I have one good news. I really mentioned that it will be available for another session, and David just responded to me, letting me know that he had not like settled on today yet, and he'll be free for next week. So we can have another session with David next week. All right.
Nice.
I guess that's it. Thanks, Amide. I really learned today, to be honest. And Diretnan for the questions. It's really good. I mean, lots of people learned from it. I was able to cover some of the questions on the group chat. Um,
All right,
I'll be
okay.
sharing out the link to the video later on and questions and so on. So I guess that'll be all. Thanks everyone for showing up.
All right. Thank you, everyone. Good night. Bye.
All right. Bye.